Hey, welcome back. This is Chapter 8. Chapter 8 is all about quality. Project quality management, starting on page 299. So, as usual, let's go over the learning objectives, make sure we got everything covered. So, we're going to learn the importance of project quality, define the quality management, understand how quality relates to the various aspects, describe quality management planning, discuss the importance of quality assurance, explain the main outputs of quality control. Understand the tools. There's a gazillion of them. The 7 basic tools and statistical sampling and Six Sigma and all the rest of those. Summarize the contributions of noteworthy quality experts. Describe how leadership and all the rest of those things relate. And then discuss how software can assist in these things. So, as always, there is an opening case study, so you really ought to pause the video and read that sucker, because we're going to be talking about it from time to time. Essentially, the case study goes like this. There's a guy who got hired, and there's an existing executive information system, and it kind of sort of works, and then sometimes the web stuff's not available, and sometimes the system slows down or doesn't work, or response time, and so the detailed reports don't match the summary reports, and there's a lot of mistakes. So this guy gets hired in to come in to kind of fix it, and that's where that story begins. Just a note: there's an awful lot of statistics in this chapter. So if you're not a math geek, it's okay, but I'm not gonna torture you on math. Okay, starting on page 300, they talk about the importance of quality management. They start with this joke. And by the way, I've heard this before, and I'm not absolutely positively certain that it's legit. It's a good story, whether or not it's legitimate. Okay, so don't get me wrong, it's great. And the idea is that the cost of computers has always been going down, and so Bill Gates made some sort of a comment that if the car industry had our level of productivity, that the cars would cost $100 and get 1,000 miles per gallon. And then, of course, the car folks came back and countered with, yeah, but, all of a sudden your car wouldn't work, and all you had to do is, stop the car, get out, jump back in, restart it, and then everything would run again. Those kinds of jokes. You've probably heard those before. Anyway, it's there on page 300. It's kind of cool. The bottom line of that is, for reasons that are not immediately clear, people just tend to tolerate software like that. I mean, for example, if you drove a car that for no frickin' reason whatsoever just stopped dead in the street, and it happened, I don't know, once a week, you'd be taking it back to the dealer saying, what the hell, fix it or give me a new one. But in the software world, something went wrong, so just reboot your computer and it'll be fine for another week. And we just put up with it. And quite frankly, we ought not be putting up with it. So, just, sure, reboot, it'll be fine. That is not the answer. We need to really get better at doing quality for IT projects. So on page 302, they start getting into it deeper. What is quality management? And, there's a gazillion definitions, and I'm not really keen on definitions. But all the definitions are kind of vague, and they even say that in the textbook, that a lot of the definitions are kind of vague, and so basically it talks about I love one. I'm going to read one of them because it's kind of cool. It says, the totality of characteristics of an entity that bear upon its ability to satisfy the stated or implied needs. Oh, wow, that was helpful. Anyway, the bottom line is quality is kind of weird. Quality management is weird. The bottom line is the customer is going to be the person who assigns the quality. Okay, he's going to be the person. He or she's going to be the person that says this meets my expectations or not. So it basically fits into 2 categories. One is conformance to the requirements. Did it meet the specifications? It was supposed to do this, this, and this, and so therefore, did it do all that? Okay, that makes kind of sense. And the other one is fitness for use. And so, does it work and is it complete? And fitness for use is a little complex. I mean, for example, if my task was to deliver you 100 computers, okay, And I delivered just the CPUs, but with no monitors and no mice and no keyboard. Have I completed my task? Well, no, because it's not fit for use. I can't do anything with it. The quality of the part you delivered may be fine, but that's not the totality of the parts. We need to have them all working together. Okay, so how suitable is it to accomplish the task? What is fitness for use? Okay, those are kind of sort of the two vague definitions that kind of tend to come up. If you talk about the purpose, what is the overall purpose for quality control management? The big picture? Well, it's to ensure the success of the product. I mean, that's kind of the big picture guy, right? And that here's a fascinating kind of a thing. If you're, again, staying at high altitude, what is the high altitude definition of management? What is that? And basically, you could say that management is meeting the needs of the stakeholders. Meeting or exceeding the needs and expectations of the stakeholders is one way of describing management. So all management is, I'm trying to make other people happy. That's what management's all about, at the big picture now, right? Okay, but one more time. Typically in a commercial world, on an IT project, it's the customer who decides whether or not you have succeeded or not, whether your quality is good or not. So it's not you. You don't get to pick. You can influence, but you don't ultimately get to pick whether or not someone says this was fit for use or it conformed to the requirements. You can help, but they're going to decide for you. So, as always in these chapters, there's this thing, the process groups. And so, yes, we're going to go through the chapters based upon these process groups. And so there's 3 of them. The planning part, and this basically talks about identifying, if there's existing quality standards that your organization is already using, you kind of need to know that. Process improvement plans and metrics and all those kinds of things. Just as a side note, when it comes to metrics, people tend to do really, really well on those things they know they're being measured on. Okay? And the converse of that is they're probably not doing as well on those things that they know that you are not collecting metrics on. It's just a human nature. The next one is performing quality assurance. Now we're going to talk about the difference between quality assurance and quality control. Okay, quality assurance is kind of the big picture kind of guy. And it's I'm doing periodic evaluations. I'm doing that kind of stuff. It's the quality assurance is all about seeing that quality control is working. Okay, so quality control is I'm down deep in the weeds and I'm measuring things and I'm calculating things and I'm rejecting a batch. I'm doing all those mechanical things to determine whether or not things meet the specifications. But quality assurance is about quality assurance doesn't go down into the field and test the product to see if it met. That's quality control. Quality assurance says, okay, quality control, are you doing what you said you were going to do? Okay, sort of like supervision, kind of. Okay, so quality control is the monitoring. It's producing those goofy little charts. It's making changes because this is a fairly common thing, and you really ought not have to be told this. But the whole point of determining whether or not something is within specifications isn't to say, "Aha! I caught you." That's not the point. The point is you go tweak the system to bring it back into specification. The whole point of having quality control isn't to punish you. It's to make the process better. That's the whole idea. And if you skip that step, if all you do is just punish people, like, I'm not going to give you a raise because 20% of your products were out of specification, that kind of stuff, that's not what quality control is about. In fact, an awful lot of companies very specifically make a distinction between quality control and performance reviews for employees. They do not tie them together, okay? Because if they did, you'd be tempted to cheat, okay? And they don't want you to cheat. What they really want you to do is to tweak the system somehow to make things come out better. Okay, so one more time. What's the difference between quality control and quality assurance? And does that sound like a test question to you guys? Okay, so quality control is down in the weeds, doing the testing, okay, actually determining compliance, okay, and quality assurance is the bigger picture, saying, okay, quality control people, are you doing what it is you said you're going to do? And maybe they might be able to update procedures and, those kinds of things at the high level, but most of the work happens at the control level, okay? That's kind of what it's all about. Okay, so having said all that, now we're going into a little bit more detail than the first one. The first one is the planning quality management. So page 304, they talk about planning. And of course they have a goofy definition. Of course they do. And their goofy definition is goofy. Planning is the ability to anticipate situations and prepare actions to account for them. Okay. Wow. Basically, if you were to cut it down to succinctly to what we're talking about in IT project world, quality planning is preventing defects. Okay? I'm trying to come up with a plan so that I'm going to make sure that defects do not occur, or at least minimizing them. Preventing defects is a continuous task. So there's this term that they talk about. I call it sensitivity analysis. They have another term for it, which, quite frankly, I'd never heard of before in my entire life, called design of experiments. I have never heard that. Anyway, but sensitivity analysis. Sensitivity analysis basically says, I've got 4 or 5 factors that are contributing to something. Is there one factor that's a little bit more important than the other? Let's say, for example, I'm trying to make my car go faster, okay? So I could lighten the car. I could make the car have more horsepower or more torque, or I could change the tires, or I could do all these other things, all these different factors. But there's probably one factor in there which is probably more important than the others. And so, sensitivity analysis basically says, of all these things, these are the ones that are going to have the most impact on my quality. So if you're going to spend time on something, spend time on those, because they're a defect way down here in what kind of tires you use is probably not going to make that big of a deal. But a defect, this analogy is getting kind of stupid, but a defect in how much horsepower I have, that's going to make a tremendous amount of difference in speed. Okay. Again, a dumb analogy, but you get the point. So sensitivity analysis is all about which variables have the most impact. And there's a little technique, which we're not going to do, a little technique that will actually pick out those things for you. Okay. So the performance of a system is often difficult to articulate. So if I was to go and say, so what is it what do you think is the success of this project? And they're going to give you 1,000 different things. So the book kind of narrows it down to a couple of examples. So the first one they talk about is functionality. And that's fairly obvious, right? How well does it perform its intended function? Does it have all the features it's supposed to have? And so they make a distinction between those must-haves and optionals. Like, you have a list of features, and these are the ones that absolutely positively must have. So those are the ones. And here's an optional ones, like if you have an opportunity, that's great. And the more of these you get, probably the better off the product will be. But, it's okay that you don't necessarily have them all. So that functionality. The next one is the system output. And this could be like screens or reports, those kinds of things. So, all those things that it produces. And there's a couple of extra features here. One is it easy to interpret? If it produces data that is not timely, not accurate, and is too complex, then it's useless, right? You need things that are in the right format for the user. And this is a good place to stop for the 15-minute mark, and we'll pick this thing up again in just a few.